Hello everyone, welcome back to a new video. Today we are diving into an exciting lab scenario that involves a common web application vulnerability, which is the path traverser. So this vulnerability allows an attacker to access files and directories they are not supposed to. And today we will explore how it works and why it's a serious concern for web developers. So in this lab, we encounter a web application that displays product images. However, there's a flaw, which is the path traversal vulnerability. So the application is striping path traversal sequences from users' applied file names before using them, and our goal is to bypass this security measure and retrieve the contents of the /etc/password file, a commonly used file on Unix-based systems containing the user information. Our objective in this lab is to retrieve the contents of the /etc/password file, and this file contains essential information about system and is a common target for attackers because it can reveal usernames and potentially weak points in the system security. So our very first step is to access the lab. So to exploit this vulnerability, we will use burpsote, which is a popular web vulnerability scanner and a proxy tool. I will just open the image in the new tab. So first intercept the request that fetches a product image using burpsote. This basically allows us to modify the parameters before they. Now I will send this request to the repeater. In the intercepted request, modify the file name parameter and try the old payloads, which is //etc/password and /etc/password response show no such file. So now we replace it with our payload, which are 4.//4. Again //4.//etc/password. So once the request is modified and sent, observe the response. You will notice that the server returns to the contents of the //etc/password file, proving the successful exploitation of the path traversal vulnerability. In our case, application is striping path traversal sequences, but it is very much essential to understand that not all sequences are treated equally. So our payload 4.//4./etc/password uses a series of dots to navigate up multiple. The reason this works is because the application sanitization process does not account for the multiple directory traversal attempts, allowing us to reach the /etc/password file. Now during our testing, we can experiment with various payloads and even more complex ones. So payload variations are designed to bypass different security measures that the application might have in place. So first things first, let's break down the given LFI payload. This might look like a string of jumbled characters, but it is a cleverly crafted sequence designed to exploit an LFI vulnerability. In this payload, %25 represents the URL encoded character % and %25 to E represents the URL encoded dot. So when decoded, the payload translates to 4.//4. both.ini. Essentially, this payload navigates through directories aiming to access sensitive files like the both.ini file on a Windows system. So this specific payload is effective when the target web application lacks proper input validation. It takes advantage of the application's failure to properly sanitize the user input, allowing it to include files that should not be accessible. This payload works in scenarios where the application directly incorporates user-supplied input into file path, enabling the attackers to traverse directories and access unauthorized files, leading to potential security breaches. But what if this payload does not work? So there is no need to worry, I've got you covered. Creating a custom LFI payload involves understanding the target system's file structure and even crafting a traversal sequence accordingly. For instance, if the server is Linux-based, you might use a payload like //etc/password to access the system's password file. On a Windows system, the target might be //windows/system32/drivers/etc/host. So understanding the context, the target operating system, and the web application's environment is crucial. Experiment with traversal sequences and file paths to find the right combination that successfully exploits the vulnerability. In conclusion, understanding path traversal vulnerabilities is very much crucial for both developers and security enthusiasts. It emphasizes the importance of input validation and proper handling of user-supplied data. For users, it is a reminder of how essential it is to keep web applications updated, as security vulnerabilities like these can have serious consequences. I hope that this lab was clear to you. See you in the next video. Thank you.